At this point, I will invite Chetna to come and talk about their use at Evolve Controls of Stream Analytics. Chetna.
Good afternoon, everyone. I'm Chetna Gupta, and I lead the technology for Evolve Controls. I want to begin with thanking Microsoft for giving me a chance to talk at Ignite for our usage of Stream Analytics in our solution. Evolve is a provider of room automation, controls, and management solutions for hotel industry. We provide our customers with trifecta of benefits: guest experience, operation savings, and energy conservation. Guest experience, we all have stayed in hotels. It's really important that the first impressions and the guest stay is very convenient. So we provide our customers with tools that they can impress the guests throughout their stay. For example, we have the ability to execute welcome scenes when the guest first arrives into the room, to give them a moment that they feel excited about being into the room. Operational savings. Hotel staff utilizes Evolve's Insight dashboard to gain visibility into what is happening in the room. If there are any issues, they have the opportunity to fix the issue even before the guest finds out that there is a problem. Energy conservation. Evolve has the ability to automatically apply or make changes to the room based on the occupancy status of the room. So hotels and operators have an ability to change the set points when the room is not occupied or is not rented. There's no point heating or cooling the room when there is nobody in the room. So our backend is able to achieve all these benefits by using a lot of Microsoft products. We are a Microsoft shop. We use Azure as a platform, use IoT Hub, cloud services, SQL databases, Stream Analytics, Cosmos DB, and a lot of things. But since we are in the session, I'm going to focus on Stream Analytics. So the use cases that we use Stream Analytics for can be divided into three categories. Hotel staff is able to gain the proof of life component by looking at the system that provides an insight into their rooms. So they can know that the room is healthy. They can get a real-time analytics on what is happening on the room, like room status, occupancy, Wi-Fi status, status of devices, is the room connected? All those information is available on their fingertips. Hotel staff has a visibility into their operations with trending information, so they can predict if there is a problem and do preventative maintenance before the issue actually happens. So before, if the hotel AC wasn't working, a guest had to call into the front desk and tell them that the room is not heating or cooling properly. Now, with all the data that we get from these devices, we are able to combine all these data points and figure out that the AC is not working optimally and can optimize their, and they can go back and fix the problem at the HVAC or the air conditioner. We also can combine the data points and create a matrix to determine the ROI and the energy consumed by the room. So all these parameters are very important because states like California require the regulation for them to calculate how much energy is being used by the rooms. So just to kind of give you an overview of our architecture at a very high level, we have a gateway that sits in the room, and all the devices are talking Z-Wave with a gateway. And as the gateway detects that there is a change in the data point, it sends out information to IoT Hub. Now, that information that goes to IoT Hub could be as simple as a change in the ambient temperature in the room because it was detected by the thermostat, or it could be a complex data point like a light switch is not working, something that our gateway has figured out by talking to the devices. And it's a very important data point for our hotel staff to know that the light switch is not working. So as the data arrive into the IoT Hub, it then gets shipped into two different Stream Analytics jobs. One is analyzing the data at real time and feeding our dashboards, and the other is really creating, sending data to storage accounts so we can have trending reports for later. So I've talked a lot about it, so I'm going to move on to the demo and show a couple of Stream Analytics jobs. And that is 6, I think. Okay. I'm going to show a couple of Stream Analytics jobs. One is really simple. As you can see, this only does is tells me if there's a change in the device status. The input to this job is IoT Hub. This is what we have all our data coming through. The setting up of input for IoT Hub was as simple as Krishna just mentioned. It was a few minutes. We just had to say an input, IoT Hub, put the configuration information, and we were done. The outputs, as you can see, there are two different outputs. One is going to blob storage, and one is going to databases. Again, really simple, and we have jobs that are going output to many different things. Then the next comes is, we have a lot of data coming on the IoT Hub, but for this Stream Analytics job, I'm only interested in a couple of different kinds of events. So we use the where clause. Again, we are a SQL development house, so everyone knows how to write a where clause. So it was very easy to filter out the events that we wanted to look at. And then we want to see if the status of the device has changed from the last time we saw the event. So we use an operator called lag, which allows us to look up previous events in the event stream. And we can know if the status has changed or not. If it has changed, we push it next to the next output. If not, then we don't really care because the status of the device is the same. The second job that I want to show you is a little bit more computational sensitive. So the intent of this job is to identify the rooms where the ambient temperature is outside the acceptable range for more than an hour. That's something that's very important to the hotels to monitor the HVAC's effectiveness. So in order to do that, we used a function called hopping window from ASA that enables us to look back at events every hour, every 5 seconds. So in the lag, there has to be an event that comes in for us to look at what was happening. In this one, every 5 seconds, we are looking for events that has happened in an hour in order for us to find out if there is a problem with the HVAC. This is a kind of a sample of a dashboard of some of the jobs that we have that we keep monitoring, and it helps us figure out the health of the system. And then we've created alerts so that we could figure out if there's a problem in the whole solution working end to end. And the other thing that we use a lot is job diagrams, and I think Krishna kind of alluded to that. We look at very simple queries where you're looking at what's happening on the plan, but one of the very important things that we use internally is the troubleshooting aspect. So if in case there is a problem with the job and I want to replay the events that might have caused it, I have the ability to do it from the click of a button, and I go hit the replay button and run it through to figure out if there is a problem with the data stream that's coming in. So that's on the demo side. Yeah, let's see. Moves back. Okay. And these are the dashboards that are available to our clients. So one of them is showing the health of a hotel, and we have the ability to drill down to the room level. The other is the HVAC utilization. This one shows the issues that are there in the hotel by room and by the device level. And the third different kind is the trending of ambient temperature. And over time, that is being powered by Power BI. So why did we use Stream Analytics? There is no cluster. We are a small company, so we don't have an army of people. So there was no cluster or infrastructure that I had to manage. We are a Microsoft shop, so skills for SQL were very easy. So it was very easy to translate to Stream Analytics. We have streams of data coming from these devices. So the technology we chose had to be able to handle Stream Analytics or streaming data. Integration to IoT Hub was as easy as adding configurations. We have more and more hotels coming online, so scalability was very important to us. And then we could send data to multiple outputs, so that reduced the number of footprints or number of Stream Analytics jobs that we needed. So what next? Krishna had a couple of good new enhancements that they've added that we are really excited. We've used the ML in preview. We're going to be using that a lot for predictive analysis, and for reactive maintenance, we're going to be using those machine learning algorithms. And also the parallel write for the database operations is very important to us, because sometimes the number of events that we get in is so much that it throttles that output. So multiple parallel writes would be great help for us. So I think that's it I had. I'm going to pass it on to Krishna.
Thank you, Chetna.